Hi everybody. Today we're going to talk about a method called volume displacement. Now in this method, it's called volume or water displacement. It's used to determine the volume of an irregularly shaped object. If the object has a regular shape, like maybe it's a cube or something like that, we could maybe use some geometric equation to solve for the volume of the object, like length or width or height. But if it's irregularly shaped, we can use this method called volume or water displacement. In this method, water is placed in a graduated cylinder. In the initial volume, the VI is recorded. Next, you carefully place the object in the water, in the graduated cylinder, which raises the volume of the water. The initial volume is then subtracted from that bigger final volume, the VF, in order to determine the volume of the object, which is called the VO, the volume of the object. So you can see in these types of problems, you're actually going to have three volumes. An initial volume of water in the graduated cylinder, a final volume of water plus the irregularly shaped object in the graduated cylinder. The VF will always be bigger than the VI. And then you're going to subtract those two, VF minus VI, to get the volume of the object. I think the directions are very important right here. We're trying to build solid mathematical skills that are going to be applied throughout this course. So I want to read and make sure we understand the directions. For each problem, and we'll model this with question number 1, for each problem, we're going to fill in a mass, volume, and density chart as shown in question 1 below here. Then we're going to write the generic equation, then we're going to write an equal sign, and we're going to plug in the appropriate numbers and units for mass and volume of the object. Finally, throughout the entire course, we want to round final answers to the correct number of significant figures, and be sure to label all final answers with the appropriate units. Okay, here's question number 1. Volume displacement is used to determine the volume of Mossy zinc. Mossy zinc, when it's made in a chemical processing plant, often is in this form called Mossy zinc. It looks like big lumps of metal that are irregularly shaped. The mass of the zinc sample is 169.2 grams. The initial volume of water in the graduated cylinder is 25.0 mils, and the final volume after placing the Mossy zinc in the graduated cylinder is 48.7 mils. We are asked to determine the density of Mossy zinc. Okay, so let's go through and find the relevant information. The mass is 169.2 grams. The initial volume of just water in the graduated cylinder is 25.0 milliliters. The final volume after placing the Mossy zinc in the graduated cylinder is 48.7 mils. We are asked to find the density of the Mossy zinc. So I'm going to put a question mark right over here. Now, to help us to visualize this, I also want to draw a little picture right over here. Here's the graduated cylinder. The initial volume read from the bottom of the meniscus would be 25.0 mils. But then this Mossy zinc is placed in there. The volume increases to a final volume read from the bottom of the meniscus of 48.7 milliliters. So you can see that this difference in volume right here is going to be the VO, the volume of the object that we dropped inside there. So all we need to do is to subtract 25 from 48.7. So I'm going to type in 48.7 minus 25. That comes out to a volume of the object of 23.7 milliliters. So this piece of metal right down here called Mossy zinc has a volume of 23.7 milliliters. Okay, like it asks right up here, I'm going to write down the initial generic equation. We're going to do that the entire year throughout the course. D equals M over V. We are asked to solve for density, so we don't need to rearrange this. So I just write another equal sign, and then I'm going to plug in the appropriate mass and volume. The mass is 169.2 grams. The volume, and specifically we're concerned with the volume of the object, it's 23.7 milliliters. put another equal sign. And now this is division. So I'm going to take 169.2, divide that by 23.7, and I get this number 7.1392. Now remember, I always encourage you guys to write down the calculator answer. Then we need to round final answers to the correct number of significant figures and label the final answer with the appropriate units. When we're thinking about rounding to significant figures, we're always going to go back to this source information that's right here. So the source information seems to have 4 significant figures, 3 significant figures, 3 significant figures, 3 significant figures. We always round to the smallest number of significant figures because we're applying the rule for multiplication and division. So we want to round to 3 significant figures, so I draw my rounding bar. Final answer, 7.14, and the units are grams per mil. Okay, final answer right there. Okay, so again, these are the steps that I want you to follow in number 2 and number 3 down here. All right, thanks a lot, guys. Have a great day.